Broadcasting from the Any Hour Services podcast studios, I'm your host, Mike Wilson, and on this episode of In the House, we're going to be talking about what causes air conditioners to freeze up and ice over. Let's go. In the House is a podcast about the major systems in the house: electrical, plumbing, heating, and air conditioning. Each week, I'm joined by a panel of experts. We pick a topic and we discuss it in depth. It's meant to be informative and hopefully bring you some value. If you've heard the show before, thanks for coming back. We'd really appreciate it if you could go and leave us a review on whatever platforms you listen to the podcast on. And if you haven't already, go ahead and subscribe so you get notified next time a new episode comes out. Like I said before, we're going to be talking about why air conditioners ice over. And to help us defrost this topic, I've got, did you like that? I couldn't wait.
Clever.
I was going to introduce you and then be like, hey, what'd you guys think of that? But I was too proud of myself.
Yeah. Clever.
Anyway, I've got Kevin and Dick with us here today to help us talk about this. They're managers over the HVAC departments at Any Hour Services. Anyway, so yeah, it's really hard to find clean jokes around the trades. Like I've thought about trying to start each episode with a joke, and then on the last episode it was a plumbing episode, and I tried to look up plumbing jokes, and they were either like, I mean, I say some dumb jokes, but like if I read a joke and I'm like, how could someone consider that a joke? That's a bad thing. Or it was like really not appropriate for our podcast. Anyway.
I've never tried looking up HVAC jokes.
I haven't either. But one of the things that we like doing at our house is once we got like Alexas all over the house, we would go around and we would just say, Alexa, tell me a joke. And it would just say a joke. But then we realized you could get super specific and you could say, tell me a teacher joke, or tell me a joke about Halloween, or whatever. And so now that's our thing. We try and see how specific we can get. You know, tell me a plumbing joke, tell me an electrical joke. And I should have consulted her before I did that last podcast, but I'm going to go home and I've got it on my phone. Let's see what happens. This is a clever experiment. You guys talk amongst yourself while I get this pulled up.
How you doing, Richard?
Fantastic, Kevin. How are you?
I'm doing pretty good.
Good. How's the installs?
They're going good. How's your service?
It's good, actually. This weather's been a little crazy.
Okay, hang on. I think it's working. Alexa. Wait, nope. Hang on. Alexa, tell me an HVAC joke.
I don't have a joke about that.
Hang on. I'm not done. Alexa, tell me an air conditioning joke.
I don't have a joke about that.
After I said so many nice things about... okay.
Hopefully you kept the receipt on those things.
Hashtag fail. No, it actually... that's not what this episode is about, but we love ours in our house. We use them as an intercom a lot because it was a really cheap way. I remember back in the day, like going and trying to wire houses because they wanted an intercom, going in each room and stuff. And now you can just plug something in. And well, I guess everyone carries around a phone that you could actually just call the person in the other room. Never mind. All right.
No, I actually use mine for that, making announcements and stuff.
Uh-huh.
No, I do that as well.
Yeah, my wife made every single room has them, and that's what she uses.
Really? See, I got mocked really heavily when, right out the gate, I was like, oh, this is awesome. I'm going to put them in every room. And I started buying them from people off of KSL for super cheap. And when I would come across somebody that had several of them, because what would happen is they would buy them during Amazon days and get them for less. And they thought they were going to make some money. And so I'd let them sit on them for a while. And then I'd come in and I'd be like, oh, I'll give you $30 for this. And they're like, it's worth this. I was like, yeah, but you bought it for this. And I'm just trying to get more for my house. And so many people text me back why do you need so many? I'm like, why you got so many questions? I got cash. Anyway, let's see. What's the show about today? Why air conditioners ice over.
Freezing up.
That was a good segue. All right, so let's just start out with the basics. How often, Richard, do you come across this out in the field, the service guys?
Oh, they come across it daily.
Daily?
Yeah, we get phone calls all the time. My air conditioner's frozen up. It's nonstop.
Now, when people say my air conditioner's frozen up, do you think they often enough know that it's got ice on it, or do they just mean it's frozen up, meaning it's not running?
No, I think they see ice.
Okay. So what is that? Is it ice? When I was younger, I used to think it was some type of weird chemical reaction. I didn't know, it looks like ice. It's cold like ice, But
Did it taste like ice? You know it did.
Kevin, you are developing a reputation for doing really weird things with your air conditioner. And
I'm asking you. I never tasted
Look,
it.
I knew
it was ice.
I did not throw grasshoppers in my air
was a smart
conditioner.
kid.
I did not go and lick the ice on the air conditioner.
Touche.
But you did?
No.
Oh, I was like,
I did the grasshopper thing, but I never did lick the ice.
that
I
is
don't-
interesting.
I don't remember ours ever freezing up.
I want to walk a day in Kevin's shoes.
Do you? Speaking of shoes, check this out.
I'll check out the In-Hour socks.
Oh, nice.
Any Hour Services socks, and there's like a little embroidered logo, like Stance. It's our truck with the little logo on the side. Those are coming soon to the swag shop.
Mike's got all the cool stuff like that.
I so do.
They're not here yet.
No. Well, I mean, this is a sample pair. So when you order things overseas where they have to like make large production runs of it, because that's the only way you can really get the price down is to do like a large quantity. When they do them, they will send you a sample before they do a run of like 800 pairs of socks.
Are they comfy?
They are actually really nice. They're like a nice woven sock. They're not too thin. Sometimes when you get like a sublimated sock, it's like super thin, but it's not even like a good thin sock, because you've got like church socks or dress socks are a thinner material, but they're woven and they're still nice. But like sometimes a sublimated sock where it's got like full color prints on the. Wait, what's the episode about? It's a process of
Supplemented?
Sublimated. It's a process of printing on the fabric. And so if you ever see those socks where they've got like the face of somebody or a full color, there's no way you could weave that kind of intricacy into the sock. You can't do it on a loom.
It's not like a silk screen.
No.
That's the old school way.
No, you don't usually silk screen socks. And on this episode, we're going to be talking about apparel production. No, silkscreen is when they like put the ink on the shirts. That's not sublimation.
Oh.
Anyway,
Yeah, I don't know any of this stuff.
that's all right. Oh, ice on the air conditioner. So is the ice safe to eat, since Kevin brought it up?
I would assume so.
It's-
I've never tried.
Honestly, it's just condensated water that's frozen. So unless you got stuff walking on it or whatever else, I don't.
So if it's up high and it looks pure and it's a hot day,
I mean, I don't know that I'd go make a snow cone out of it.
I was just about to bring up snow cone. Like,
I mean,
if you had,
maybe if you were starving and you had some extra snow cone juice and you're like, hey, let's.
I don't know that starving, like if I'm like really hungry, I don't know that
Maybe-
like snow
maybe
cone
you're-
is what I think.
Maybe you're a guy who's
If you're
really
parched
missing the
and
snow
it's hot.
shack.
I'm starting to think maybe just not a day in Kevin's shoes, but in his head. Like
Well,
There's only-
I would like to point out, I'm probably the one that has like derailed this the most
Yeah.
and in the most directions.
I've been the quietest so far. I'm going to point that out now.
Speaking of being quiet, I'm just kidding. Okay, so back to the air conditioner. So you say it's just condensation that is frozen. So I mean, it is ice. Let's talk about the reasons, the most common reasons that an air conditioner ices up, and maybe what we can do about some of those things. So what would you say is maybe the most common thing?
we get a lot in the first of the year when we first start turning air conditioners on. Dirty air filter. That's probably the most common thing the first of the year, is because people are first turning them on. So all the ones that should work properly because the filters weren't changed, they freeze up. That's a big one right the first of the year. It kind of comes in waves of what we see.
So let's take a step back, because when you bring up the air filter as a basic for a lot of the causes, well, I don't know, because like with the filter, that's a lack of airflow, right? Because I mean, cooling the air and the refrigerant is really just a process of heat transfer, right? And so in the summer, you're trying to take heat out of the air that you're conditioning, and in the winter you're trying to put heat back into the air. And so that process of trying to take heat out of the air means you've got this refrigerant that's really cold, and as the air blows over it, that's how you remove the heat. It is blowing across these cold coils, and when you don't have enough warm air going across these coils to remove that heat, or to remove the heat from the air, or reverse to like absorb some of that cold, that's when you start having issues with it icing over, right? Okay, so dirty air filter is a common one. You you actually pointed out that like, oh, that's more common in the beginning of the season. So you don't have that throughout the.
No, we do. We definitely do. But air conditioners are going to break. Usually, well, I mean, there's several different reasons. I mean, you could be low on refrigerant. You'll hear me say refrigerant freon. I just use it as a term.
Sure.
So if you're low on that, that'll cause it. I mean, all winter long it sits there, it's pressurized, so you can be leaking throughout the year. But we still get those calls the first of the year. But those first calls with the dirty filter seem to be at the first of it, and then people change it, and then it reminds them. So we still get them throughout the season.
Also, at the first of the year, when people are leaving the covers on their air conditioners, does that cause it to ice over, or does that cause the system to overheat? Overheat with the compressor and all the things inside there.
Yeah, it'll shut down.
Okay, good to know. All right, so reason number 1, dirty air filter. Obviously, the solution to that would be to, make sure you've got a clean air filter. Another one, another one? Actually, I'll go in order off my outline since you guys don't have it in front of you.
I have it in
front of me. Oh, you do? Okay, cool. So, Kevin, or Richard, what's another reason that
was very nice.
Well,
I feel singled out.
Well,
did you bring your iPad?
I brought my phone. I actually tried to pull it up, but it wouldn't let me in.
I brought mine.
Just saying.
Well, I shared it with you.
I know, but for some reason it won't let me pull it up.
Anyway.
Well, interesting you asked that question, Mike.
Just saying.
You know what else is too many registers are closed off or returns are blocked. That's another great idea.
So talk to us about that one while I take a picture of this list and send it to Kevin so he can pull it up on his phone.
See, look.
Oh, wait, you got it?
No, I got it, but it won't let me open it because for some reason
What's it say?
Says, you need access.
Oh, if only there was a button that says request access.
And I request access.
Did you? It's going to be easy. There, I see it come through right there. Look, I'm going to go into. That's the second time?
Uh-huh.
I'm not the greatest at checking my emails.
He was busy with his socks, Kevin. All right.
Open those. Hey,
can you put me down for 10 pairs of socks?
10 pair.
Yeah,
when they come in, yeah.
I'd be able to.
I think they'd be awesome for the uniforms because, you got the black pants and.
I'm just thinking for any time.
Well, okay. Oh, wait. Okay. So let me send this. I think I just shared it with you. Share. Are you sure you want to share? The character of this person requesting it is questionable. What? Google? I'm just kidding. I made that up.
No,
okay. So
it could be
cool
true.
thing about these socks. Check this out.
Oh.
On the top of the socks, I got the core values. You got win, 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 honesty and integrity, hard work, fully invested.
Nice.
Right?
Those are actually cool. I like the red on there.
Now my foot's like 1 foot is cold.
Well, it's like 15 degrees in here.
Well, yeah, but our air conditioner's
awesome.
not freezing up.
Yeah, no kidding. And it's working good.
Okay, anyone on the camera watching, I didn't want to have one cold foot, so I kicked the other shoe off because I didn't want to bend down and untie my shoe and put it back on. Too much information. This is a really bad podcast. Okay, so anyone listening, we'll get back to the show, I promise. Right now. Okay, so another reason that air conditioners freeze up, the registers. So a lot of people think that I'm going to close the registers off in rooms that I'm not using because a really common thing is people have hot and cold spots in the house, and in the summertime, you don't want to be in a hot room. And so I know that I can understand why the logic would say, okay, I'm going to take the air that would be going into this room that I'm not using. I'm going to close off the vents, and that'll just pump more cold air into another room. So talk to me about why closing off vents and doing things like that, why that could have a negative effect and cause the system to ice over.
Furnaces and air conditioners are designed to move so much air. And if you have too many vents closed, it's going to cause back pressure. It's going to cause the system to work harder. So that's where we get to where the airflow, same thing. You get that coil, it's just getting colder and colder and colder. You need 16 vents or whatever it is. You close off too many vents, it's going to do the same thing as a dirty filter. You don't have the air movement you need, and it's going to freeze up.
The thing that can happen, the pipes that are ran to the different vents, they can only handle so much air based on the amount of force that's being pushed by that blower motor. And so, if it's already maxed out and you close off these vents, those are still going to blow the same amount. If you've got tons of vents, yeah, it could help in certain scenarios. But typically, if you're going to be like that, then you've got way more vents than you needed to begin with. I think that you probably run more into not having enough vents in your duct design for the size of the AC. And that's a lot of what happens. You're borderline with your amount of airflow capacity. And so you start closing those off, and you were already right there on the cusp of just having enough. And so they start getting closed, and that's where it cuts the airflow down and you get froze.
Yeah. Another one with the return vents, I see a lot in homes. I don't know why, and maybe you can answer this since you guys have done new construction. Like, of all the places that you could put the return airs, they seem to put them exactly like in the middle of a wall where someone would want to put a couch or an entertainment center. And so people like cover the things up with like furniture and things like that. And maybe it's because they don't understand, what the purpose of that thing is. But anyway.
Yeah, we try to, during construction, it's hard. You don't know where the customer's going to lay it out, and you've got to kind of design it to where your ductwork and everything works. But it's really hard. That's one thing we see quite a bit. Somebody goes and buys a big new couch or a new entertainment stand. It's like, hey, let's block this cold air return. And it's like, well, my air conditioner used to work, but now it's a problem. It's like, what have you changed? Oh, I haven't changed anything. Oh, wait, I added this big, huge entertainment, and I cut this out, or we remodeled it, and we did away with that. So we see that quite a bit as well. Return air is blocked.
A lot of times when you do new construction, you're putting returns in the only places you can find even put them, because when they do all the engineering and stuff on a house, they are not planning on airflow. They absolutely do not plan on it, right? And
I hear that said by every trade though. So who's like planning? Like plumbers are like, they don't plan for the plumbing. They don't plan for the electrical. What are they planning for?
Good question.
Couches,
yes.
the TV.
Okay, well, that works. Kevin, did you get in? Do you have the outline or?
I haven't even tried since you did there.
The whole purpose of me like putting on that show and distracting everyone was so I distracted so well that like you were distracted. Man, that didn't work very well.
Hey, look, there it is.
It is. Okay, you're in there. So I don't know. What's another thing that could cause air conditioners to freeze up?
Kevin, why don't you take this one?
Oh, yes. I was trying not to talk too much.
You fell.
Fail.
Dang it. Well,
3.
I just had to look and read down it. Shut up.
And you don't have to like read the exact words and make it sound like we're reading them. It's really just like a thought starter.
Coincidentally, a plugged evaporator coil can also cause your coil to freeze up.
All right. So not everyone knows what an evaporator coil is, and they don't know what it means to be plugged. So let's break that down for people. So what is that?
Well, we were talking about coils, right? You got two sets of coils. The ones that's outside is the condensing coil. One that's inside that sits on top of your furnace is your evaporator coil. That's the coil that's actually during the AC process that's going to be getting cold, right? So typically when you're going to freeze up, that's where it's going to freeze up first.
So the coils in the system is the magic behind that heat transfer process. So you've got the refrigerant that we talk about is running in these copper tubes back and forth between these coils. When it's in the house, it is removing heat from the air and making the air cold. And outside, it is then removing heat from the refrigerant, and so that it can send cold refrigerant back into the house. And so that circulation there, all those processes, the most important thing, I know in one of my videos jokingly I said, the most important thing in real estate is what? Location, location, location. But in air conditioning or HVAC, the most important thing is airflow, airflow, airflow. And so that airflow is super important. So the coil that is, and to explain what the coils look like, if you haven't seen, maybe you've seen the one outside, but if you think about a radiator, like in the front of your car, how it's got those thin metal pieces, and that is made to help keep the engine cool because you've got the air blowing across it, and you've got a fan that assists that in a car. Your air conditioner is very similar, except you're just trying to see, this is distracting. I'm not sure what you just did.
I sent you a picture of a coil, so we talked yesterday about maybe doing some pictures during the podcast. So I sent you a picture of a coil that's pretty open. That was one of my guys that took this picture.
Oh, I got you one that's opened and iced over.
It's starting to ice over, as you can see. Yep, because like Kevin said earlier, we get the call a lot that
we should have set a what's it called, like time lapse on that to like show the ice forming.
Cool.
Could we simulate something like that? Like just grab a coil from the thing and do a thing with the thing.
You could do something.
Yeah. No, we could just take the cover off and have the air come by. That would be really.
I wasn't quite sure if it was like something that was like useful or if I had said something like really wrong and you were like trying to not call me out on the show or something.
Mike, stop being an idiot.
No, that coil right there that's a pretty good picture.
That's just known.
That's a good picture of one. So
Yeah, no, that is. We'll throw that up on the screen. Austin, remind me to text that to you.
we get that a lot. People are like, oh, my air conditioner's froze up. They let it thaw out outside and think, oh, it's good now, but it's actually the inside that starts, and that can get to be like a block of ice, 3 inches of ice, and that takes hours and hours and hours to cool.
Gotcha.
Yeah, a lot of times you got to let it sit overnight.
Got it. So, okay, so we start. So that's what a coil is, and there's 2 coils. There's one outside and there's one inside. Now, talk to us about how that gets plugged up and how airflow ties into that.
With the coil on the inside,
Yeah.
we're talking about the evaporator coil still.
Well, I don't know that we totally explained it for people to understand what a plugged, evaporator coil is.
So, I was just looking through your list. The thing that people need to understand is 90% of the reasons that thing's going to freeze up has to do with airflow, right? And so what are the things that are going to restrict your airflow? We already talked about filter. The evaporator coil, when you look at it, if you get in there and you see a nice clean one, it looks like what? Kind of like a filter, but it's looks like a radiator kind of. You know what I mean? And so
I do, because that's why I pointed out the radiator, like parallel that I drew.
Mike, you're being an
I'm being a technician
you're being a jerk again.
or technician.
Kevin, quit being an
Okay.
No, so but you've got the evaporator coil, which reduces the airflow if it gets plugged up. And I got to say, some of these coils, when you go to them, they are way clogged up. I mean,
So tell me how that happens. Like, what's it clogged up with?
A filter. The filter doesn't. If the
It's
filter
clogged up with a filter?
No. So
Almost.
if the filter isn't installed properly, air is
It
getting
looks
bypassed.
like a wool sweater.
no, really,
with
I have literally peeled off an inch thick, where it just peels right off, and you could take it and make fabric.
Yeah, so it's plugged up with dirt, animal
Anything that
hair.
can be flowing
hair.
through your airstream.
Yeah, usually that's a sign of a bad filtration system,
Right.
Where your filter isn't doing its job properly. You've got air bypassing the filter somehow.
Big thing that happens, people just don't replace their filter often enough. And I mean, how many collapsed filters do you see? Because they've been in there for so long, they're so plugged up. The suctions finally pull them into where there's a gap.
Right, it's a one. Most of them are a really
1 inch
inexpensive
filter.
1-inch filter, and when you aren't allowing any air to come through, you've got this really strong motor that's creating a lot of force, and air has mass, and it's going to try and move, and it's going to move things out of its way, and so that filter, like you just said, it'll collapse, and so it'll start pulling everything that the filter was supposed to catch. It'll start pulling it, and it'll start collecting on the coil. And as that collects, it does just like the filter, and it won't let air pass through. And when you don't have air passing over that coil, that's when you start having the thing start to ice over.
When it's properly balanced, excuse me.
When what's balanced?
The refrigerant, your AC system, you've got the refrigerant in there based off of temperatures and pressures and everything else and airflow. There's a balance you have to, excuse me. There's a balance you have to achieve, right? And so once something in that balance starts to get offset, and we're talking about airflow, then that's when it starts to freeze. So where's I going with that? I had something good.
I'm not sure. I got distracted by your cough, and I was going to say there's a bottle of water if you need.
That distracted me too.
Gotcha.
But anyway, so with your evaporator coil,
Yes.
when it's getting plugged off, that's not the only coil that can get plugged off, right? You've got your evaporator coil that sits up above, but if you've got a high efficiency furnace down below, you can have the secondary heat exchanger, which can get plugged off also, which has a similar type coil that's down below. Okay.
Stay up there on the mic so that you're not getting too far away.
I just feel like I need a cough again, so I'm.
Yeah, but like you're not coughing, you're talking. So you're like I'm gonna try and like avoid the cough, but I'm gonna talk over here.
Mike, dear Mike, you're being.
What is it about? I'm just like trying to make sure it's a good audio experience for anyone listening. That's all. Sorry, listeners.
Thank you, Mike.
Your guests don't care as much about your ear and the sound quality and all of that stuff.
Awkward silence. Okay, Kevin, continue on your
I don't
dirty
remember
coil. You're talking about the
So we
secondary.
talked, okay, so
I don't remember what I was talking about.
we talked about a plug coil, right? Okay, so other things. I think we talked that one to death. But we talked about there being 2 coils. So is it, and maybe I'm wrong here, I don't know, but like the coil plugging up inside, we talked about the cover being over the outside unit and that causing it to overheat. So if the coil on the outside gets plugged, is the more common thing overheating, or does that also contribute to the thing icing over?
More common to overheating.
Really? Okay.
Yeah, it's more common overheating because that air isn't
Cold.
moving through there, so it's more common that.
I gotcha. But would that contribute, if that's overheating and not doing its job, would that reduce like the pressure or something and cause the temperature to drop at the coil inside, or not really?
It's going to cause my pressure to go higher.
Okay.
On my high side.
And there's a correlation between the pressure and the temperature of the refrigerant. So if it goes up, so that's not necessarily going to cause it to ice over.
Here's the thing with air conditioning. You can have a little of everything, and it makes a big difference.
Sure.
So that's a big challenge with air conditioning. You can go out, and it could be just a little bit of an a dirty filter, a little dirty coil, a little low, a little plugged here. And that makes a big difference. All of those
things add up.
All those things add up. So it's kind of hard to say that, yes, this can or cannot be alone on that one. Well,
and what we're really just trying to do is say, here's like what happens most of the time. So if that's not a huge contributing factor, then, that's cool. It might.
That one's not going to be huge.
Okay, cool. This is where the panel of experts have to chime in and let us know what's going on. You actually alluded to something. You started talking about low refrigerant earlier, and I think that a lot of people think, oh, it's low on refrigerant. That's going to not make it ice over because you think ice, that's extra cold. Low refrigerant, I think a lot of people think if it's low on refrigerant, it's not going to be as cold. So talk to me about how low refrigerant can cause it to ice over.
Heat transfer is just not as good, so it's basically turning to vapor too soon.
Okay.
So that one we get a lot. That's probably the second most common problem we run into.
Okay.
Dirty filter, it's hard to say which one's the most, but low refrigerant we get a ton. It's just not doing its job, and so it gets too low. It gets below that 32 degrees, and so it starts freezing up. We see that a lot. And again, that leaks, Kevin, you probably agree with me, most leaks are inside the coil.
Yeah.
So they get rust in there, corrosion, and they start leaking a little bit. Then throughout the year they leak, and hey, it worked fine last year, but this year it doesn't. It's leaked out. So those are my favorite calls that we get. Not really, but it's like, hey, I just need some more gas. Give me some more gas and I'll be fine. It's like, you've done this several times, haven't you? Oh yeah. It's like, well, that means there's a problem. You should never have to fill your air conditioner ever. If you do, there's a problem. Gotcha.
Okay, so low refrigerant can cause the system to ice over. What about I heard someone talk one time about how your system, like because of the science and the physics of heat transfer, you can't just dial up Antarctica. As much as like some HVAC companies want to get on the radio and say, oh, we'll put in a system you can dial up Antarctica. Like, you can't go as low as you want to because you're limited with how much lower you can go. So talk to me about that process. Like, I guess where I'm going is if someone is trying to set their thermostat too low and like essentially like work the thing too hard, I guess Talk to me about that.
If you set your thermostat extremely low.
Who's like tapping with their fingers?
Kevin. He's fidgety. Kevin, you need to hear.
I just heard it like going on.
I'm tapping my foot now. I'm good.
That's why we put carpet down.
Yeah, we're good.
So on that one, if you set, for example, like my house, I can turn my air conditioner as low as I want, and it's only going to get down to so low. It's not going to get any lower because it's doing its job. It's removing all the heat it can to keep up. If it's 95 degrees, it won't freeze up. It's just not going to. It's going to run. Now, if it's colder outside and you run that thing and it gets down to 65, then yes, it can freeze up. But if it's on a hot day and it runs all day, it's not going to freeze up. If it does, there's a problem.
Gotcha. So that might be something that might happen at the beginning of the season if somebody's really aggressive trying to cool the house, or maybe in the fall or something.
Yeah, if somebody turns their air conditioner, finally that spring first day, and they just crank their air conditioner, like it's hot, and they grab the thermostat and turn it down to 60, forget to change it back, and then next morning they wake up, it's frozen. It's because they turned it too low and the ambient outside was too cold.
Gotcha.
So there is some truth there, but on a hot day, if it freezes up, you've got a problem.
Hot day in the middle of the summer.
Yeah.
Okay. Let's see. What else? What are some other things that cause your system to freeze up?
You requested access.
Well, complained about not having access in it. It is funny. If only we knew this was a show where I ask questions that I give you in advance.
Good times.
Okay.
So obviously you've got on the list that your blower motor is bad.
Okay.
Essentially, again,
I'm not the expert. I mean, I don't want to like keep drawing attention to the fact that we have an outline,
I send
but
you questions that I send you, right? Questions that I send you, but I'm not the expert.
Right?
If we're not going off the questions that he sends us, then
he's asking us questions. Do we want to go there? Do we want to go to why Mike has to send the outline? You guys are busy, and like I don't know as much as I'm like, hey guys, it'd be really good on these technical episodes if you guys, kind of gave me some outlines, but it doesn't happen. So I end up sending something out from the limited knowledge that I have. Like I know more than the average person, but I've got a limited knowledge, and so
I feel slightly chastised.
I haven't said anything, so this is all aimed at you, Kevin.
So if you have a bad blower motor,
it's aimed at everyone that joins me on this show. Anyway, sorry. So I guess my point is the outline, I send it to you, and on me, I send it like super last minute, but like that's your opportunity to like go through and be like, oh, that's a stupid one. It doesn't contribute. Or like this one. So yeah. So
I think you do a bang up job.
Yeah.
Thank you.
I'd say that.
That was my way.
Yeah.
Maybe not using those words.
So when you do go and review the show, I know I say it all the time, but I'm very sensitive. I'm fishing for compliments, and so be generous with those. Mike, I think your topics and outlines, the way the show flows is awesome. Anyway, so we talked about airflow, and a big contributor to how much airflow you have can be that big, huge motor.
Yeah. Blower motor, if it's not running at the right RPMs, we had a big controversy when we started calling it a squirrel cage.
I was just going to
if your blower
glad
wheel,
you said that.
Ooh, the controversy.
Hamster wheel, I think you said it was.
I did not say that it was a hamster wheel, but the way that you described it, the fact that it goes around and around, and it's placed in the same position that a hamster wheel would be placed, and that it spins like that, I was just saying that a hamster wheel feels like a more accurately described, picture of what the blower fan is, and a squirrel cage makes me think of a trap.
No?
If it makes you feel any better, I would love to see a hamster in one of those.
Well, Mister, I throw grasshoppers in the outside coil.
Powered by the hamster, not powered by the motor.
Kids listening, especially the Van Orman kids, like, do not go and grab your hamster and put it in.
Yeah, my kids don't have a hamster.
Yeah.
For good reason.
You have dogs, right?
Oh yeah.
One's like in labor, right? Like having some puppies.
Yes, indeed.
You're really. Do you breed dogs, or it just that particular?
No, I you're gonna have to cut some stuff here because
okay,
I got lots of funny stuff in my head.
No. Okay. We'll go away. I only brought that up because we were laughing about that earlier.
I was about to say
no, don't say it.
Well, no, Mike. Just saying. That's what was in my head.
Here's the thing, Kevin. You recognized.
Look at the note, the time on that.
That's got to come out. Here's the thing. You recognized that you shouldn't say it.
I know.
I apologize. You were so proud of the joke that you were like, I can't save this one. Nah, it's coming out.
Yeah.
But I'm going to preface and say,
you guys do such a good job cutting and splicing this.
12 seconds later.
If the fan wheel, we're going to call it the blower wheel.
You can call it whatever you want.
If it gets super dirty, you get a lot of the just gunk that gets caked on it.
Yep.
It'll actually reduce your airflow also. You notice how all these go back to airflow.
Yep.
You know? But it does. You can pull those blower wheels out, and they will have, just piles of stuff just stuck to them, which is bad for a couple reasons, but one of them is it cuts down the airflow.
If you think about it, like how many times have you looked up at a ceiling fan and seen that layer of dust and fuzz that builds up on the leading edge of the blade? Your squirrel cage, hamster wheel, your blower motor fan, that has tons of leading edges, and if you're not keeping a clean air filter or something happens and it collapses, that same dust and dirt that's building up on the coil is building up on the leading edge of the blades on that blower motor, and you're same thing. You're like reducing the airflow,
and they can get really plugged up.
They're spinning. A lot of those motors are like 1,075 RPMs.
Yeah. So we'll just lump the motor into like as one thing, but the motor, not the motor, but the fan can be dirty and not moving enough air. If the motor goes out completely and it's not running, that can not, obviously that's not moving air. But then in relation to that, if you've got some type of communication issue or the circuit board's not working and sending, the motor might be fine, but it's not getting the message or power from the circuit board to turn on, that also is going to be an issue there.
I think I just found me an overflow service tech here. I'm going to start putting you in a service truck when we get like slam busy like today.
As long as you review the outlines that I send you before I go on the call.
I reviewed them. Somebody that didn't have access didn't review them.
No, I had access on my other computer. I read it.
Oh, okay. You're just acting like you didn't.
I just didn't have it here.
Oh, got it.
But yeah, the circuit board, like I said, there's whatever can cause that blower not to spin can cause it to freeze up.
Okay, and so then one that I found as I was doing research that I actually don't understand to the level that I'm going to need you guys to explain to people, and as you're explain it as technical as you want, and I'll be sure to slow you down and say, okay, I don't get that. But a restricted metering device. Talk to us about what a metering device is and why that would contribute.
I'm going to try an analogy, and I don't know if it's going to work out, but I'm going to try it.
All right.
So imagine a stream of water flowing down the mountain in the middle of winter.
Okay.
It's going to freeze, but it's not going to fully freeze, correct?
Okay.
Now imagine just a little trickle. What's going to happen?
It's going to freeze.
Entirely.
Yeah.
It's kind of the same thing. We get a restriction inside the copper tubing and anything. We don't have enough refrigerant flowing. It's going to freeze solid.
What's the metering device, though?
So it's a little device that
is it like a TXV or like different things like that?
So there's a TXV and there's a piston.
Got it.
So the TXV allows the metering device to open or close depending on the temperature outside and the temperature of the tubings.
So is that simulating the same thing that happens when you've got low refrigerant because it's not letting enough refrigerant go by? Is that what the metering device is doing? Is it's metering it too much, or what's happening?
No, it can. If you get like something, if there's a piece of metal or something like that from your compressor breaks off and blocks that metering device is designed to do a certain thing, and that basically with the amount of refrigerant going through the coil, if it gets blocked, it'll cause a problem.
Gotcha.
And the TXV, it opens and closes. Let's say if it gets stuck closed, it's not allowing enough in there.
Gotcha. Okay. All right. Well, let's talk about what a homeowner should do. So we talked about here are all the things that could happen, but if you're listening to the show and you're like, cool, well, I got one. Now what do I do? So what do we do if we end up with we find ice on, where are the places that they're going to see the ice? Because we talked about the coil, the inside coil starting most of the time where it freezes up, but most people don't see that device.
No,
so where are they going to see the ice?
Most people see it outside.
Really?
They're outside doing yard work or playing or out on the patio and they notice ice on the air conditioner. That's where they'll first see it. But if you want to really first see it, you'll see it downstairs on the copper tubing where it comes out of the coil. And
since it is condensation, you're probably only going to see it where you don't have insulation, right? Because that insulation is supposed to help, so you don't have the condensation there. So wherever you end up with condensation, that's where you're going to end up seeing the ice. So you can see it down where the refrigerant lines are just going into the.
Do you want me to send you another picture, Mike?
Sure. I will not get distracted this time.
Okay, don't get distracted.
I'll get distracted a little bit because you actually told me that you were going to do it and it like took the conversation over. But that was smart to warn me that it was going to come through. And okay, back to it.
One thing to point out, just because you don't see ice outside or anywhere else does not mean it's not frozen. It can still be frozen. There's varying levels of frozen.
That's true because it might freeze there at the coil, and the longer it goes on, the longer it runs, the ice kind of works its way out.
I've seen coils where they've got a skiff of ice, and I've seen coils where they were from side to side of your entire duct plenum that's there, where they're frozen solid.
What is a skiff? Like, I know the American system of measurements and metric, but like, what is a skiff?
I think you should ask Alexa.
I'll send you a table later.
Hang on. Hang on, this is going to be a new thing on the show. Let me get to my Alexa app here. All right.
You want to bet next time we come back here, there's going to be an Alexa sitting?
There might be. Hang on. And we'll mic her up. Alexa, what is a skiff of ice?
Here's something I found on the web. According to reference.com, the term skiff refers to a wide range of small boats that generally have flat bottoms.
So there's a boat of ice on the on the coil. So for those listening that are actually listening to the words that we say, words are powerful, Kevin.
Yes, they are. We're going to say a slight coating.
Okay. That couldn't have been better. When I was thinking skiff, when I think of skiff itself, like I knew what you were saying.
Oh yes, I know you did.
But that was much more entertaining than anyway. All right. So you've seen everything. I honestly didn't hear what you said after Skiff of Ice because I was not practicing active listening. It was one of those situations where I heard something. I was like, well, I'm going to be nice and not interrupt him, but I'm going to like throw this comment out there.
Dear Mike, quit being a jerk. Send.
You've said that a lot this
Good thing
episode.
at least you let him know so he's not getting distracted with it.
Anyone listening, like leave me a comment or in your review, let me know how this interview style works. Am I the problem here on the show or is it the guests? I'm just kidding. Be nice. I'm too sensitive. Say it's them. Let's see. Okay. So you've seen all kinds of things, and that ice working its way out from the coil can end up at the compressor. The compressor outside can end up frozen up.
Yeah, you can have the entire system be froze solid. I mean, how many times you've seen condensers where the compressor itself has inches and inches that cover the entire thing. But at the same time, you
Several
can have
skiffs.
Several skiffs.
Several.
It's skiffed times 10. So the coil itself, though, all it takes is enough ice to block off the airflow.
Yes.
And so that doesn't mean it has to be solid, and that doesn't mean that it's going to be frozen all the way out to the condenser.
Yeah.
All that means is that the potential is there that it could be covered. So just because you don't see ice doesn't mean it's not frozen. It still could be frozen.
Perfect. So let's say that, I guess in this situation, to answer this question, it would be to the point where they notice some ice, because you were saying we get calls all the time where people are like, hey, my air conditioner is frozen up. Like they see something, they know it's froze up. So what is the first step? Because like you can't troubleshoot that when it's still a block of ice, because in order to troubleshoot a system, it has to be running, right?
Yeah, we tell him to shut it off.
Okay.
Shut the air conditioner off.
Okay, so shut the air conditioner off, because if you keep the air conditioner on, it's just going to get worse because it's trying to like
Keeps it frozen.
Right. And I would say this. Now that is the best advice for, blanket to everyone. But if you understand and you know how to make sure that your air conditioner isn't running, but you can run the fan, that will help speed the process of defrosting the ice.
If you're a little more advanced, what I would tell you is go outside to your disconnect on your air conditioner and shut the disconnect off and leave everything else as is.
Got it. Okay. Good advice. Now, but that also brings us to, a warning that we need to give people. If it is iced over and this thing is defrosting, what are some of the things that could be happening, or let's warn them about what could happen?
You're going to get a lot of water.
Yes.
Water, if you've got that furnace running, that blower motor running, water can get on those electrical components and possibly damage it.
Yeah.
So I haven't had a lot of that, but I would just be, full disclaimer, there is a risk of that.
Yeah, you can, even the condensate drains that come off, when you look at the front of the coil, you got that little 3/4 inch PVC pipe that comes and goes down to the floor drain.
Yep.
Or to a pump. They can freeze to the point where that's actually plugged off and the water doesn't have anywhere to go. So as it melts, it just flows down into the furnace itself. And so there is that potential. So you definitely, I'll be honest, the safest is the most gradual. Just turn it off.
Turn it off and let it go.
The problem is usually when it's at that point, it's 100 degrees outside and you're hot and you want it done fast.
Yeah.
I don't know
And
if
so-
anybody's patient when they're hot.
No one is.
Right. So you got the drip pan underneath, but like when it's up in an attic, you don't want that thing flooding in an attic. Like there's a lot of things that could happen. So if you do shut the system off, you're probably going to see some water on the floor as it's like draining, and that's not necessarily a bad thing, but you want the technician to also take a look at, what damage did that water, melting inside? Did it run down into the components of the furnace and different things like that? So, well, I mean, we've covered.
So, well, no, I want to touch on when you're telling us what to do.
Yep. Go for it.
So make sure the filter's clean.
Yes.
That's number one thing I would tell someone is your filter clean. If it's dirty, then that's possibly all it is. And I say possibly because we don't know that. That's where we always start. Check the filter. because that's going to tell us, do we have enough airflow? Then we can continue to diagnose. If you shut it off and then let it unthaw all the way, check the coil, make sure those lines are unthawed as well. I'd leave it at least 6 hours to unthaw. Check the filter. If you want to try it again, make sure your vents are all open. If you want to try it again and it freezes up again, you've got a problem.
Okay.
Then it's going to be more diagnosing, and with the refrigerant and stuff, we'll need to get our gauges on there and really see what's going on with it.
Okay. Any final words, Kevin?
No.
That was a final word.
Dang it.
Trick question. That's the show. We'll be back next Tuesday with a new episode of In the House. We'll be talking about the part 2 of our generator series. We talked about portable generators in the first episode 20, if you want to go back and listen to that. So next week, we'll be talking about standby generators, the bigger ones, where you can actually have enough power to run your air conditioner.
I'm going to.
If the power goes out. You have one?
No, I need to get mine.
You're going to get one?
Yes.
There you go.
I want one.
Well, if you want to know and do a little bit of research, you could listen to, episode, whatever the next episode is.
24.
24. Is this one 23?
This one's 23.
All right. There you go. Well,
Austin held up to 3. I'm guessing that's what it meant. It's 23. Yeah,
got it.
He's nodding his head.
All right. Well, there you go. Don't forget to subscribe to the show so that you get notified next time a new episode is released. If you have some time, again, please go review the show. That's how we know if you like the show or if you don't. We hope you mostly like the show. I'd like to thank everyone that made today's show possible, my guests and everyone behind the scenes. If you'd like to know more about Any Hour Services, visit anyhourservices.com. I've been your host, Mike Wilson, and you've been listening to In the House. See ya.